for coming. Just a couple words about CommScope. CommScope is an infrastructure company, global. We deal with wireless, Wi-Fi, fiber optics, copper networks, enterprise, service providers across the broad spectrum. So the topic today is we're going to share what we think are some ways, 8 ways in fact, that you can build networks that are going to be ready and enable you to sort of march down that road towards Terabit Ethernet as time goes forward. So why consider a seemingly extreme network speed today? And the reality today is that every internet minute sees millions of user transactions. The type and content of these applications continue to proliferate. And the volume of data that goes into a data center is growing exponentially, has been growing exponentially for decades, and it's expected to increase by 25 to 35% per year going forward. So we actually look at ways to try and build different kind of applications and different kind of infrastructures to suit that need. And it seems certain that the pressure on data centers is going to continue to increase exponentially. Meeting the demands requires a redesign of the applications housed in the data center. Using multiple parallel resources is the common way to increase capacity for applications and services. What that means essentially is that the servers, as they work together in parallel, generate a lot of east-west or internal traffic in data centers. And that puts a lot of pressure on the infrastructure, the network infrastructure that supports it. So there's a lot more fiber. The fiber links have to operate at higher speeds. And from that perspective, there's a lot of pressure on the actual underlying infrastructure, our part of the network, in order to put something in place that can actually have that kind of runway going forward. So we'll talk a little bit about how we can do that going forward. So innovation in network technologies is really kind of the optical modulation schemes, speeds, fiber apparatus, ways of vision multiplexing. There's a number of tools that are being used to increase capacity for optic links. The industry standards at the same time are really struggling to keep pace. So we have 400 gigs coming out this year. We've added 25, 50, 200. And we're actually looking now at introducing new applications for multi-mode fiber, a few fiber kind of applications to support 200, 400 gigs as well. So lots of things coming out. At the same time, we also see a lot of pressure and I guess rapid development pressure. So we see MSAs kind of leapfrogging the standards process. So new things coming out like shortwave division multiplexing for multi-mode fiber. So the road ahead is a little bit twisted and not so easy to judge. So as an infrastructure guy in our world, right, it's difficult to try and understand, how do we plan for such rapid change and such an unreliable kind of future view. So we'll talk a little bit about those 8 ways to get ready for the road ahead. With the applications, changing all the time, and with such sort of a difficult and unclear future, we'll talk about maybe where do you start and how do you actually put together a view forward. So we think probably the best way to look at this is to think about the end view, and with that in mind, we really want an infrastructure that is sustainable, productive, and cost efficient. So start with a few tips. So tip number 1 really is look for a high density and ultra low loss kind of network components. Leaf and spine mesh networks really support east-west data traffic, fantastic. It puts a lot of pressure and complexity into the network though. So where we used to have high speeds, really at the core, we now have high speeds throughout data centers. Those links are longer, there's a lot more of them. So from that perspective, we are building mesh networks. We're looking for more fiber, and that really means that we have to now take apparatus and redo it and reinvent it so that it really can provide these 2 attributes, much higher speed and much lower loss. The other thing is that if you noticed before, we're talking about using in some cases 2 fiber applications, in some cases parallel fiber applications. We need some sort of methodology to look for sort of consistent kind of polarity management, whether it's 2 fiber, whether it's parallel applications. Plug-and-play fiber optic systems really have a real advantage in terms of being agile, being deployed across data centers quickly, single mode, multi-mode. But what you really need in the management system for polarity is something that just works when you plug it in. So it doesn't matter if it's single mode, it doesn't matter if it's multi-mode, it doesn't matter if you're using 2 fiber applications or if you're using 8 fiber applications. So Method B is the industry recognized standard. The enhancements to Method B really is just taking out all of the issues that we had with transceiver polarity, for instance. So transceivers have pins. Unfortunately, the modules that we used to use for plug-and-play systems also had pins, so that creates polarity issues. Now you have to have different kinds of ports, do cross-connect and equipment connections and so on. So enhancing that, looking for the kind of enhancements that have come out now. All the single mode transceivers issues and angles and so on have been solved, so that's really where the Method B enhancements come in. So that's something to look for when you're, a good tip to look for. Tip number 3 is really think about using high bandwidth media. So there's the choice, do you do single mode, do you do multi-mode? The multi-mode, there's recently been a fiber introduced and standardized, it's OM5. The advantage of OM5 really is that it supports multiple wavelengths on multi-mode fiber, much as we've been doing on single mode for a long time. So the advantage of that is it really extends the reach of these multi-wavelength applications. So if you think about the Cisco BiDi, for instance, right? It works on OM3, it works on OM4, but there's a distance limitation to the technology. It's about 150 meters on OM4. If you were to install OM5, the distance would be approximately 250 meters. So much longer reach. You can also, if you use low loss apparatus, you can span multiple links. So you can have 2 or 3 links in a data center. You can maintain the structured cabling. You can maintain that kind of flexible and agile approach. So high bandwidth media combined with low loss apparatus gives you sort of longer reach and support. So if you were to think ahead and think about some of the new applications that are coming out, shortwave division multiplexing, for instance, that actually will support 40 gigs, similar to the BiDi, but instead of 150 or 250 meters on OM5, that's more like 400 meters. So much longer support, different applications in buildings, risers, and so on. Also, the SWDM technologies are going to be available, probably BiDi technologies will be available shortly. That will be approximately 150 meters until the specs come out. It's hard to say exactly how far they'll go, but certainly much longer reach and supported with high bandwidth multi-mode fiber, OM5 multi-mode fiber. Single mode fiber, similar kinds of concerns that are coming out in the short reach data center applications. The overall link budget for 500 meter applications, short reach applications, really means that you've got 3 dB to play with. Every dB of loss that you add from apparatus really decreases the reach very, very quickly. So again, a focus on low insertion loss and high bandwidth. So those are good tools to think about. Next thing is there's a real pressure in the data center to increase density. So we see that in many different areas. So what we are really looking at here is combining not only high density, but also manageability. So fiber management, access, that's the key to being able to move things quickly, but also make sure that it's reliable going forward. The other thing that we want to look at is flexibility. So look for things like 24 fiber, higher density applications for trunking in particular. So if you think about putting 24 fibers in the same connector size as an 8 or 12 fiber MPL connector, you end up with much higher cross-sectional densities and pathways and spaces in data centers. So that's another thing that you should look for. Certainly you want to be able to support the 12 fiber legacy infrastructures. At the same time, you want to be able to add 8 fiber where it makes sense. It doesn't make sense everywhere in a data center. It's not a trunking application typically, but it is something that you should be able to support as well. So look for that. The other thing we think, next tip would be to add automation where you can. Automation becomes very important for documentation, for thinking about in these complex kind of MPO to duplex kind of breakout scenarios. Very difficult to label and keep track of what goes where, what QSFP ports that maps into what server and so on. So these kinds of tools will allow you to do that. becoming a lot more popular for conformance and compliance as well. So good idea to think about that. The other thing that we think you might want to look into is designing with the applications in mind. So the optic applications that you want to support going forward. A little bit different design here, so you should be really looking at specifying the best kind of end-to-end link performance that you can get. So we know that standards-based insertion loss and so on is not good enough anymore, right? We're looking for the best possible insertion loss. If you specify that end-to-end, then what you're essentially saying is, no, I will not accept the maximum value for every component in the link. I want to know what that link will conform to. So the question becomes, what should that number be? So you need to have a tool in place that actually allows you to build these links, to understand the best performance you can get from those links. And then on top of that, you want some design tools that will help you understand, if I go to higher speeds, will this be supported? If I go to higher speeds, are the link distances going to be too long? So from that perspective, you should be looking for design tools that actually guarantee that you will get supported distances and supported application support in the future. So those are the kinds of tools that I would suggest we look for. Finally, look for a good partner and a good team. So from a global perspective, you should be looking for leveraging industry experience, developing development experience, standards participation as well, and I think kind of the scope to manage across networks. So not only wired, but wireless, Wi-Fi, and so on. So those are the kinds of tools that are going to be needed, and the team is probably the only way you're going to be able to get enough information and enough data points to understand and predict where things are going in the future. So from, I think I'm almost done here, the roadmap for Terabit Ethernet might look like, packing the right stuff, having the right bandwidth, the right engine to achieve higher speeds, the lowest loss, waste not, want not, keep as much signal as you can. That gives you flexibility for topology, gives you flexibility for future speeds going forward. You also might think about that GPS system, so the intelligence systems, a map to the future, good design tools, and then finally guaranteed application support. Those are the kinds of things you can mix into a good roadmap for a Terabit Ethernet. And I think I've just about exhausted my time. Thank you very much.
How about a nice thank you to